Hey everyone. So today we're going to be kind of carrying on with this idea about like taking all the little pieces that we've learned this year and kind of starting to stitch them together. Yesterday we did acid-base neutralizations. So acid-base neutralizations, remember, is basically you had like a concentration of hydrogen ions, then you had to take it to moles, then you did your stoich step. Then you had that gave you moles of OH, and then that you brought that to the concentration of OH, or maybe you did milliliters, or something like that. And this is going to be a very common theme that you're going to have to do. Um, the questions will give you something. It's not going to be moles. Um, it will be a concentration or a mass or something like that, and then you're going to have to convert that to moles, balance an equation, then do some stoichiometry to go from moles of something to moles of something else in the reaction, and then you'll have to convert that uh, to like a concentration again. This is going to be something that it happens fairly often, and in fact, you're going to see this. This is basically the basis of the law of chemistry, where or the calculations of it. So, I want to show you one other weird way that this happens. I'm just going to have you do one problem today, a single problem, but it's a bit of a doozy. So I'm going to go through and do a reaction, not a reaction, a example problem for you. So, and it's going to be very similar. You just follow the same steps as me to do that. All right, so here's the example problem. All right, and a student is performing a redox reaction with manganate iodide ions to form elemental iodine and manganese 2 ions in a 1 liter acidic solution, pH 5.3. What is the new pH if the student uses 3.12 times 10 to the negative 7th moles of manganate ions? All right, so there's a lot here. But again, remember, you just have to figure out what is it that we're after, what do we know, and it's going to make things a little bit easier on you. All right, so always go for what is, what will, how is, look for the question. What are they actually looking for? We're going to be looking for pH. Well, how do we get pH? We're going to need H plus ions. And it says this is the new, so this is the final one. So if we're talking about a new pH, we also need to think about the old pH. What was the original pH? All right, we have that. So if we're gonna need H plus ions, we're probably gonna also need the initial H plus ions. What was it at the beginning? And we have that with pH. They gave us the pH there. So going from pH to concentration of hydrogen ions is pretty simple, pretty straightforward. You guys can do that, right? How do we go from an initial to a final? Well, that means we are going to have some kind of change, right? Somehow in this reaction, we are either going to gain or lose hydrogen ions. It's either going to be used up or they're going to be created. It's a reaction. So we don't know what that's going to be. If they're used up, if they're a product, they're going to get used up, and we're going to subtract this, whatever it is, from the initial. If it's a reactant, or if it's a product, it's going to be created. Therefore, we're going to add them together. So we have to just kind of think about what is happening here. Okay, and then that will get us the concentration of hydrogen ions for the final, and we can convert that to pH. All right. It's pretty simple to go from pH to the initial, so I'm not going to worry about that right now. I'm just going to figure out this first. how do we know how much the hydrogen ions change? Well, they give us a reaction. They don't give us the formula, but they give us this word formula for it. So we're going to have to go through and think, okay, what is manganate? Manganate is MnO4 minus iodide ions. Well, you guys know that. It's just I minus. It's an ion, iodide ion. And this is going to form elemental iodine, I2, all right, and manganese 2 ions. So it's going to be manganese ions, and we know that it's 2, so it's 2 plus. So this is going to be our unbalanced redox formula or equation. All right, cool. I'm going to switch over to a blank sheet now. So it's going to be, now we just have to balance this. And remember, when you're balancing redox reactions, you want to split them up into the reduction and oxidation. Here, it looks like the iodine is losing electrons. So this is the oxidation step. And if you go through and do this, this is manganese's +7 oxidation number, +7 to 2 plus. That's going to be, excuse me, in this case, we're gaining electrons and gaining negative charges. So this is going to be your reduction step. It's pretty easy to tell what the two steps are going to be. So let me rewrite those, separate them out. Manganese going to, or manganate going to manganese ions. And then we also are going to have iodide ion going to elemental iodine. Okay, cool. So now we're going to remember, we're going to have to just go through that process of redox balancing. Step 1, we wrote them out. Great. Step 2, balance everything but oxygen and hydrogen. Looking through at the top one, no need to balance. 1 and 1 manganese. Here we're going to have to balance 2 I minus, 2 iodides, because we have I2. Okay. Next step, oxygens. Balance it by adding water to the other side. So we have O4, no oxygen on this side, so it's going to be 4 H2Os on this side. Bottom one we don't have to worry about. Next step, H plus. H plus balance all hydrogens by adding H plus to the other side. We have 8 H pluses on this side. There we go. None down here. Next step, charge. This bottom one, we're going to have to fix the charge. We have 2 negative on this side, neutral on this side, so we need to add 2 electrons to this side. All right. Here we have 8 plus and a minus, 7 plus on this side, 2 minus on this side. So that means to balance this out, we are going to need, what is that, 7, 8, 9? 9 electrons? No, not 9. 7. Oh, it's manganese 2. Yeah, this should be plus. There was my mistake. So yeah, that is going to be 5 electrons. There we go. Okay, so 5 electrons on this side. Once we have that, we need to make these electrons balanced. To do that, we multiply the top one by 2, bottom one by 5. This way we have 10 electrons on top, 10 electrons on bottom. 10 electrons being produced, 10 electrons being consumed. All right. Let's go through, do that. So this is going to be 10 and 16, 2, 2, and 8. This one is going to be 10, 5, and 10. All right, cool. So now we're going to need to combine these back together. Remember, cross out anything on both sides. The electrons get crossed out. Nothing else gets crossed out here. So that's going to leave us 16H plus 2 manganate plus 10 iodide going to 2 manganese 2 ion plus 5 elemental iodine plus 8 H2O. Great. Awesome. So now we have this scenario going on. And this looks crazy. You can go through, it's always a good idea to double check these things. So we have 10 minus, 2 minus, 12 minus, and 16 plus. So that's a total of 4 plus. Over here, we have 4 plus. So charges work out. And it's always a good idea to double check yourself and make sure everything is balanced on both sides if you have time. Now, the thing is that when we're doing stoichiometry, we don't care about most of this. Think back about what we want. We want hydrogen ion concentration, so we're going to need hydrogen ions. And what is it that they gave us? You can see manganate ions. They gave us manganate ions. So that is going to be what we're going to need. We're going to need those two things. So 2, 16. Those two numbers. 2 manganate, 16 hydrogen ions. That is going to be what we are after. All right. Sweeping all that away. How many is it? 3.14 times 10 to the negative 7th moles. So write this down. 3.12 times 10 to the negative 7th moles of manganate. All right. So that's where we're going to start. They started us with moles. Great. We didn't actually have to even convert to moles. But this is going to be the start of our stoic step. The start of our stoic step. Our next step is going to be the stoichiometry. We want manganate on bottom and H plus on top. And it was 2 to 16. Manganates cancel. And now we have moles of H plus. And we don't want moles, we want concentration. We need the concentration. So it was 1 liter. How do I know it was 1 liter? Problem tells us 1 liter. Great. Now we can go through and double check this. So 3.14 to the negative 7th times 16 divided by 2 is going to be 2.496. Let's just say 2.5. 2.5 times 10 to the negative 6th. Cool. So 2.5 times 10 to the negative 6th. All right, and this is going to be the hydrogen ion concentration that we have used up. And since it's using up, we're going to be subtracting this. We're getting rid of it. Okay? And what was the initial pH? It was 5.3. The initial pH was 5.3, which means 5.3 negative that is 5 times 10 to the negative 6th. All right, then. 5.0 times 10 to the negative 6th. And that means that the final molarity of this is going to be 2.5 times 10 to the negative 6th. All right. And to figure out the pH of this, what we need to do is do log of this, the negative log, and it's going to be 5.6. Cool. So it may not seem like a lot, but we went from 5.3 to 5.6 with this reaction. So we did change the pH. All right. So there's that. That's going to be your thing of this. This is going to be your guys. No, that's not right. 2.6 times 10 to the negative fourth. There we go. All right. This is going to be your guys's problem. Sulfite, manganate ions, sulfate, manganese ions, different pH, different moles of manganate ions. It's going to be very similar though. So just follow along with what I did and you guys should be good. This is going to be on Canvas as well, this problem. So you don't just have to pause the video. All right, guys. It's a bit of a doozy problem, but it kind of will show you the whole process of doing this. This is definitely much more of a free response question where you can take a bit of time. You can take 5-10 minutes on a single problem, as opposed to a multiple choice where it's you're a bit on a time crunch. All right, guys, if you have any problems, questions, comments, concerns, you know how to find me. Send me a message on Remind or wherever, and I will, I can hop into a Teams meeting or just refer back to you, or just message back to you. All right, have a good one, guys. See you later.